Hello, Assalamualaikum everyone. I'm Dr. Sumaya from University of Malaya. I'm actually a postdoctoral research fellow in aging group research. Okay, today I'm going to talk about normality tests. Okay, this clip is actually a continuation from my first clip on SPSS, introduction to SPSS. Okay, uh, today in this clip we're going to learn how to do normality test. So actually an assessment of normality is a prerequisite for many statistical tests because normal data is actually underlying assumption in parametric testing. Okay, so if you are going to do a student t-test, ANOVA or linear regression, you will need to make sure your data is normally distributed. Okay. So, in my data set, uh, we will decide on our independent and dependent variable first. Okay, so my dependent variable here will be the continuous variable, which is BMI and age. Okay, because we would like to test the distribution. And my factor or my independent variable here, it will be the false. Okay, so we would like to compare between fallers and non-fallers who what is their mean age between fallers and non-fallers, who is the older or the younger, and also we would like to test on the BMI, whether fallers are more likely to be obese or the non-faller more likely to be obese. Okay, so we go to analyze, descriptive statistic, and explore. Okay, remember just a three-step: analyze, descriptive statistic, and explore. Okay, click on that. It will come out like this. Again, just now I've told you about my dependent list will be the continuous variable, which is age and also BMI. So you can put together age and BMI, so it won't change or affect your result. And my factor just now I would like to compare between fallers and non-fallers, so it will be my false will be my factor list. Okay. Next, we will go to the plots button and click on histogram and also normality plots with test. This is the most important uh, things here. Don't forget to click this, otherwise you can't really know the normality test like Kolmogorov-Smirnov and Shapiro-Wilks results. Okay, continue. Okay, we would like to see both statistic and plots. Okay, click OK. So this is the output will look like. It will come up with case processing summary. Okay, so for as we all know that as we have decided, we would like to compare between those with no history of fall and non and also fallers. So they will come out like this. Okay, for the summary for non-fallers and also fallers on their age data and BMI. Okay. So from missing, we can see that 3.1% or about 5 people in the non-fallers group has no data on their age and also on their BMI. Likewise, for the the fallers, 7 of them had missing data. Okay, so maybe you will need to clean up the data after the analysis. Okay. Second table will be the descriptive table. So it will show you the mean, median, variance, and deviation, minimum, maximum, all the descriptive analysis on the age in this subgroup. Only in this none with no history of falls. So it will show you the skewness, whether it's skewed to the left or skewed to the right, if the and also the kurtosis, whether the curve is very much higher like this or very much landai, which is very much lower. Okay, and also for both data, continuous data, which is age and BMI. Okay. The main result for this output is actually this one, the test of normality. So I've mentioned before, which is the Kolmogorov-Smirnov and also Shapiro-Wilk. So from this table, the most important thing is the significant values. Okay, so if the significant values is less than 0.05, indicates that it is not normally distributed. Okay, remember that. Okay, if it's more than 0.05 means it is normally distributed. Okay, so for here BMI in fallers, actually the distribution is normal, but in other three like age in non-history of fall or age in fallers and BMI in with no history of falls, the distribution is not normal. Okay, where to use when to use Kolmogorov-Smirnov or Shapiro-Wilk? It depends on your sample size. For my data set, I have 370. Therefore, I will be using Kolmogorov-Smirnov. While Shapiro-Wilk, it will be better to be used in a smaller sample size. Okay. So this is the graph that will come up. Okay, so remember in normality test we can look at graph or the normality test itself. Okay, so from here how to indicate whether it's skewed or not, you can just see like using eyeball, or you can actually add a distribution curve. Double click on the graph, go to elements and show distribution curve. Okay, so here you can see that actually the data is not distributed in the center. It's actually skewed to the left. Okay, so let's see how the BMI among the non-followers. Okay, which one? Okay, the last one. Okay, BMI among the followers again. Okay, this one is normal, right? Just now, so we show distribution curve. Okay, so we can see that the curve is actually at the center. It's not skewed. That's why the test of normality, it is not significant. Okay, so that's the gist of the test of normality. So we can indicate that, or we can decide that to compare age, we will need to be used the non-parametric test. For BMI, as only one of it is significant, means we still need to use non-parametric test. Okay, I think that's all for today for normality test. I hope it will help you on conducting the test. Okay, thank you for listening.